So hello, good day. So today we want to look at some of the applications of differentiation, right? Okay, one of which is tangent and normal to a curve. Okay. Okay. So now, what's a tangent and what's a normal? Okay. When we have this graph, a graph, and in this graph we have a curve, right? And we have a point on this curve. If a line passes through that point, just that one point on the curve, that line is called a tangent. So this is a tangent to a curve. It passes through just one point on the curve. Okay. Now, if a line is drawn to be perpendicular to that tangent, that particular line is called normal. So the line that is perpendicular to a tangent is called a normal. Okay. Now, you see this line. What is the equation of this line? That is given gradient and 1 point. Equation of this line. Equation of the tangents. You know the equation of the tangents, is the gradient of the tangent, which is the differentiation of that curve at that point. Right? That is this M, let's call this one M1, and call the gradient of this one M2. You see, the gradient of this tangent, it's the y ds. It's the y dx of that tangent is the differentiation of this curve, right? That is the differentiation of this curve, the y dx. That is, if we have a curve which has a particular equation, which is y could be probably 4x squared plus 3x plus 4 or plus 2, whatever. Now, if we differentiate this curve, then we now substitute the value of this value, these points, the x and y here. If we call it x1, this one y1. If we substitute this value here, which is x1, y1, if we substitute it into this differentiation, it's going to be the gradient of the tangent, right? Okay, so m1 is going to be the y dx, right? At x1, y1, right? Okay, and this particular gradient of this curve, for instance, for this one is going to be 8x plus 3. We now substitute x1 and y1. Let's say we have a value for x1 and y1. Okay, if for instance this one is 3 and this one is for instance 2. Okay, if we substitute 2 and 3 here, so let's say this one x is 2, so that's going to be 8 into 2 plus 3, and that's 16 plus 3, that will be what? 19, right? So which means the gradient of that curve is 19, right? Now we can also find the gradient of this normal, because this tangent and normal, they have a relationship, and the relationship is that the angle between them is 90 degree. This angle 90 degree. So how do we find the gradient of this normal? And if we know the gradient of the normal, then we can find the equation of the normal. You get it? Okay, now what is the equation of the tangent? We have its gradient now. If we have a gradient of the tangent and we have a point, given gradient and 1 point, the equation of the tangent is going to be, when you have m and you have x1 and y1, right? So the gradient of that is going to be y minus y1, equation of a straight line. That's y minus y1, that will be m into x minus x1. This is the equation of that tangent, right? Is a straight line, equation of a straight line, right? Given the gradient and 1 point. We can also find the equation of this normal, given the gradient and 1 point. Yes, they are passing through the same point, right? So we can also get it once we know the gradient of m2. So how do we get m2? Now m2, to get it, To get M2, now if you look at this very well, you will see that this is M1, and this is, let's say this is theta 1, right? And this is M2, M2. Let's say this is theta 2, right? You see this angle and this angle. What is the angle here? We know angle on the straight line is 180. So this is going to be 180 minus theta 2, right? And then we know that if we add this and this together, it's going to be this angle. That's the exterior angle of a triangle is equal to the interior opposite angle, right? If we add this and this, it's going to be equal to this angle, right? So that's the angle between them. So which means the angle between these two is what? This one plus this, right? So that is theta 1 plus 180 minus theta 2. Okay, these two angles, right? And tan of that angle, tan of theta 1 plus 180 minus theta 2 is the same thing as tan 90. And what is tan 90? Tan 90 is infinity, right? It's infinity, right? So which means this expression is going to be infinity. And what will make this expression equal to infinity? If we apply the the tangent formula, our identity, the identity formula, when we say tan theta 1 plus tan theta 2 is going to be tan theta 1 plus tan theta 2, 1 minus tan theta 1 tan theta 2. Okay? So what will make this undefined? That is when the denominator is equal to 0, right? So that is when this denominator is equal to 0. That is when this will be undefined, will be infinity, right? So for infinity to be achieved, for this to be equal to tan 90, then 1 minus tan theta 1 tan theta 2 will be equal to 0. Just take the denominator of that expression and equate it to 0. And that is the equation we are looking for here. Okay? Now, don't forget that this theta 2 here is what? Is this 180 minus theta 2? It's not just this. So we don't confuse them, right? So we call this is 180 minus theta 2. 180 minus theta 2. This is supposed to be 180 minus theta 2. Okay? Is equals to 0. And then what is tan 180 minus theta 2? That is in the second quadrant. If we use this particular formula, we can still express it. We're going to get minus tan theta 2, right? Tan 180 minus theta 2 is same thing as minus tan theta 2 because that is in the second quadrant. And we can verify that by using this formula to slot in 180 and theta, because tan 180 is 0, right? So if you put 0 here, put 0 here, you'll be having minus tan theta 2 as your final answer, right? Okay, so this is now going to be 1 minus tan theta 1 times minus tan theta 2 equals to 0. So that will be 1 plus tan theta 1 tan theta 2, right? Okay, from here now equals to 0. From here now, tan theta 1 tan theta 2 is equals to minus 1. Is equals to minus 1. But what is tan theta 1 and what is tan theta 2? Tan theta 1 is same thing as M1 and tan theta 2 is same thing as M2. So that means M1, M2 will be equals to minus 1. So this is the equation that connects the tangent and the normal together. So which means if we know M1, we can find M2. And if we know M2, we can find M1. Okay? So M2 from here is going to be 1 minus 1 all over M1. So from here that we got M1 to be 19, M2 is going to be 1 all over 19. And if we know the gradient, then we can find equation of that normal, right? Because we know the points. Okay, so that's how we get it. So this is what we want to establish. The connection between the tangent and the normal, their gradients. They are all passing through the same point. Okay? Okay, so that's it. Thank you.